Okay. Number 2 says, calculate the mass of the residue left when 2.4 grams of sodium hydrogen carbonate is decomposed by heat. Now, those who looked at carbon and its compounds, or when you looked at salts, when you heat sodium hydrogen carbonate solid, what does it go to? When you heat sodium hydrogen carbonate, because they are telling us what is the mass of the residue left when 2.4 grams of sodium hydrogen carbonate is decomposed by heat. Decomposition meaning they have heat the thing until no further change. So when you heat sodium hydrogen carbonate, what do you form? We looked at it under salts, heating of carbonates.
We form sodium carbonate.
Sodium carbonate, correct.
Carbon dioxide and water.
Carbon dioxide and water. Now, if that equation is correct, let's try to balance it up. This is a solid, this is a gas, this is a liquid, or water in a gaseous state, because they will all evaporate, isn't it? The water is in a gaseous state. So now, if you balance this, you see 2 hydrogens here, here there is 1, carbon is okay. So let's start. 2 sodiums, put 2 here. So these are 2 sodiums, okay? 2 carbonates, now 6 oxygens. This is 3 plus 2 plus 1. Meaning, our equation is almost there. Hydrogens, there are 2, correct? Oxygens are 6 balanced. Therefore, the equation is balanced. Because the agenda of this, the main idea of this is write a well-balanced equation for the reaction. That's number 1. Number 2, write down the moles of substance that concerns the question. That's where we are going. The moles of the substance that concerns the question. Let's go. What is the question saying? The question is calculate the mass of the residue. What is the residue? If this gas goes away, this one goes away. The residue left is sodium what? Carbonate.
Carbonate.
Calculate the mass of the residue left when 2.4 grams of sodium hydrogen carbonate is decomposed by heat. Now, the moles, because step 2, this is a well-balanced equation. That's step 1. Step 2 says, write the moles that concerns, okay, what concerns the question? In our question, we have sodium hydrogen carbonate and the residue. Now, you say 2 moles of sodium hydrogen carbonate produced 1 mole of sodium carbonate. Isn't it the statement we have written now? Concerning, write the moles that concern the equation here. Where is that statement? It says 2. Write down the moles of substances that concern the question. Leave what is not concerning the question. Leave it out, like this carbon dioxide and water. Leave it out. If they ask for the mass of carbon dioxide produced, you must also look for it. Now you take this and carbon dioxide. If they want water, you take this and water, because this is what they have given you. So here, the third one says convert the moles to grams. That is all. From the equation, they are saying the mass of the residue left when 2.4 grams of sodium hydrogen carbonate is decomposed. First, look for what this is. You say sodium hydrogen carbonate is, sodium is what? 23. We are looking for relative atomic mass. We are converting now these to grams. Now hydrogen is 1 plus carbon, which is 12 plus 16 times 3. What do you get? Start with 16 times 3, add it to 13 plus 23. What is the answer?
$84.
84.
That is good if we are attentive. Now they are saying 2 moles. This is 1 mole. Remember, this is 1 mole. Now they are saying there are 2 moles. What about sodium carbonate here? It is 23 times 2 plus 12 plus 16 times 3. What is the answer?
$106.
106 grams. Now you say 2 moles of sodium hydrogen carbonate will be 2 times 84 grams of sodium hydrogen carbonate produced 1 mole, which is 106 grams of sodium carbonate. That is from there. Now 84 times 2, you get what?
168.
68.
168 grams of sodium hydrogen carbonate, sorry, produced 106 grams of sodium carbonate. Now, what about 1 gram? Because the question is telling us 2.4 grams of this. So what about 1 gram of sodium hydrogen carbonate? It produced 106 divided by 168 grams of sodium carbonate. Ask yourself a question. What about 2.4 grams? What does it produce? 106 divided by 168 times 2.4 grams of sodium carbonate. What is the answer here?
1.5143.
1.5143 grams of sodium carbonate. Is it the answer we have on the screen?
Yes.
Good. So now, someone is asking a question.
Patricia.
Patricia, you're asking.
Let me see the equation.
The equation up here. The equation is there up.
I can't see it.
The equation. Now is it clear? Patricia, you have disappeared. Where have you gone?
Very well. Yes.
It is now clear.
Yes.
Okay, very good. So that's why you start from anything here, even sodium hydroxide and hydrochloric acid. There is nothing here. They say sodium hydroxide was neutralized by the hydrochloric acid. You write sodium hydroxide plus hydrochloric acid. The end product is sodium chloride plus water. Now, if you evaporate this, try to balance 1, 1, chloride is 1, water. You see this? So there is 1 hydrogen here, 1 hydrogen. Those are 2 plus oxygen. That is water. Full balance, right? The states. This is aqueous. This is aqueous. This is aqueous. This is a liquid. The rest is balancing. Now, after writing a well-balanced equation, go to the second step that stays, write the moles of the substance that concerns the equation. The moles of substance that concerns the equation is sodium hydroxide and the chloride produced. They want to calculate the mass of the sodium chloride produced. When you evaporate, the water goes away. When you evaporate, water goes away. So what remains is hydroxide and this. Forget about hydrochloric acid and the water. No, unless they ask for hydrochloric acid somewhere in another part. Now, like this equation of ours, they can ask for sodium carbonate, the mass of carbon dioxide produced. Yes, if they ask for the mass of carbon dioxide produced, don't waste time struggling with the sodium carbonate, go straight to the hydrogen carbonate and write the moles that concerns the question. You say 2 moles of this produce 1 mole of carbon dioxide. Convert carbon dioxide to grams, convert this one to grams. You say 84 times 2 of this one produced 44 grams of carbon dioxide. What about 2.4 grams? What does it produce? That is all. Hope I was sound and clear and not so fast.
Yes.
You can now calculate the rest of the numbers down. Okay, so that is your exercise. You have 1, you have 3, you have 4 and 5. As you do those numbers, try to read and know what do they want. Now here they're asking, what is the mass of sodium oxide? What mass of sodium oxide would be formed or would be made from 1.5 grams of sodium? Now this is a reaction of sodium and what?
Oxygen.
Sodium and oxygen.
And oxygen.
Thank you very much. So if you cannot write the correct formula of sodium oxide, and then you balance the equation between sodium and oxygen and you form sodium oxide, then you balance. The answer you get, if you don't get this answer, you know there is a problem with the equation of reaction. Okay, if that is done, allow me go to our subheading or point of discussion for today. Please, if there is any question, ask before I move to the next part. Now you have the time to ask questions. We can go at a slow pace, the one you can know, you can use. But if you have understood, all is fine. Are we all okay?
Me, I'm okay.
Sure.
Okay. Mm. Okay, since silence in Africa means a yes for everyone, let me go to the next point of discussion. This molecular theory of gases, you find them in physics. So we shall not look at Boyle's law. We shall not look at Charles' law. If you want to know, go and read physics properly. These are minor things because they say Boyle's law is that the volume of a given gas, the volume of a given mass of a gas is inversely proportional to its pressure at constant temperature. If the temperature is constant, the volume is inversely proportional to, so this is the expression, volume is inversely proportional to 1 out of P, which is pressure. Then you put equal sign, when you put equal sign, you put in a letter. You can say maybe in a constant K out of P. Then you take P the other side, it becomes PV, which is a constant. Now, if you know the equation is constant, you say P1 V1 is equal to P2 V2, which is equal to P3 V3, equal to P4 V4, because they are said it's equal to a constant. That is Boyle's law. Charles' law, volume of a given mass of a gas is directly proportional to the temperature. The other one, the volume was proportional to the inversely proportional to the pressure. Now here they are saying volume is of a given gas directly proportional to the temperature. That's why V is directly proportional to T mathematically. When you put a constant in a letter KW, you say V is equal to a constant times T. Then you say V out of T, you are dividing by T, is equal to a constant. Meaning V1 out of T1 is equal to V2 out of T2. It can also be V3 out of T3 as you go on, since they are constant. So all that gives us the ideal equation as this. Combining all the two together, you get this ideal equation. So this one I'm not going to struggle here. Our main point of discussion is this man here and this one. After this, whatever comes in a moral concept, make sure you discipline it. And practice makes perfect. You don't say, I've understood mole concept and stop there. The numbers keep being tricked every day. So if you don't discover the trick in them, following those ideas we have given you, then this concept is going to be hard. But for now, whatever we have passed through, I see people saying yes, meaning everything is okay. So this man says the Guylusac'S law. This is the third law describing the behavior of gases when involved in a chemical reaction. For him, he took his law basing on gases, that when gases react, they do so in volumes. They do so in volumes. Now, I want us to compare this law and the one below here of Avogadro. Avogadro. The Avogadro says the law states that equal volume of gases, equal volume is for Guylusac'S law. Avogadro says equal volume of gases at the same temperature and pressure contain the same number of molecules or moles. That is all. Now, you replace volumes from Guylusac'S law and put it in Avogadro. You replace volume by moles. We're going to look at examples and we shall see how they vary. So when gases react, they do so in volumes which bear a simple ratio to one another. They bear a simple ratio to one another. We saw even from calculation of masses, converting masses to grams, we saw if you cannot write a well-balanced equation, you can never know the moles to which those substances react. You can never know the volumes to which those things react. So they are saying they do so in volumes which bear a simple ratio to one another and to the volume of the products formed. If gaseous, provided the temperature and pressure remains constant. This law will be asked for at an advanced level, but now at this level, understand its application because a question will just be brought. This hydrogen and oxygen reacted to form water. Find a volume of maybe oxygen that was used. So you must know the volume ratios. So Guylusac'S studied the chemical reactions between gases and noticed that there is always a very simple ratio between the volume of gases that react together. For example, here, hydrogen and oxygen gave us water. Now here they are saying 2 volumes instead of moles. They say 2 volumes of hydrogen combined with 1 volume of oxygen to form 2 volumes of steam. This is steam, water in a gaseous state. Somebody give me the description of this. Since it is cold, someone can start dozing. Someone give me the description of this. Peace. Give me the description of number 2. Because number 1 is saying 2 volumes of hydrogen reacted with 1 volume of oxygen to give us 2 volumes of water or steam. Peace. Number 2.
I'm not sure, but let me just try.
Please do so. The equation is there, it is well balanced.
Okay, hydrogen gas plus chlorine gas giving us hydrogen chloride.
Use volumes, the mole ratios, the ratios we had. Use volume just like the way I've described here. They are saying 2. 2 is from hydrogen, isn't it? 2 of hydrogen,
yes,
combined with the 1 of oxygen to give us 2 of steam. That is water at gaseous state. Then here, use the same. How many are here on hydrogen?
1.
1. How many on chlorine?
1.
1. How many were produced?
1.
Here, how many are
2.
there? 2 of hydrogen
2
chloride.
chloride.
Okay, so the thing is 1 volume of hydrogen combines with 1 volume of chlorine to form 2 volumes of hydrogen chloride gas. Now, here they are saying 1 of nitrogen combined with 3 of hydrogen to form 2 volumes of ammonia gas, which is this: 1 nitrogen, 3 hydrogen, 2 ammonia gas. That's what you form. 1 volume of this combined with the 3 volumes of hydrogen to give us 2 volumes of ammonia gas. Now let's look at an example here. They are saying 100 cubic centimeters of hydrogen. Now the first statement goes back to our steps we used in the calculations above. The first statement was to write a well-balanced equation. They are saying 100 cubic centimeters of hydrogen were burnt in excess chlorine. Determine the volume of chlorine used. So here they are saying hydrogen burns in chlorine to give us hydrogen chloride gas. Now, if you try to balance, this is hydrogen chloride, which is 2. This is a gas, this is a gas, this is a gas. Have you seen solids in this equation?
No.
No. So the man said he took his relation to gases. He studied the behavior of what? Of gases.
Gases.
Okay. So when you see a question with the gases everywhere, you know this is a very simple thing to do. Study the mole ratios or the volume ratios, 2, 1, 0, like that. The rest you go. As long as you can come up with a correct equation. Now, this paper here, I don't know where I put it. I'm also going to put it under study material, and you'll also get it. This one. It will help you write some of this. So here, we have gases. All gases occur as molecules. They are always 2, not 1. When they say hydrogen gas, they are 2. Chlorine gas, they are 2. Oxygen, they are 2. Like that, bromine, iodine. It is different from a bromide. It is different from a chloride. It is different from all those are iodide. Comes from iodine. So that's how they behave. So that's what is there. So they are saying this is now, they will not direct you and tell you this is the equation, but you must be positioned to know that hydrogen was burnt in excess chlorine to form a gas. Which gas is that? It's called hydrogen chloride. So this is a well-balanced equation of that thing, of the reaction. If you cannot come up with a well-balanced equation, then this concept of Guylusac'S law will give you always hard time. So they are saying 100 of hydrogen were burnt in excess chlorine. Determine the volume of chlorine used. This one is just very easy. Just come and say 1 volume, since they are considering volumes, 1 volume of hydrogen. Because from here, we are looking at the numbers behind, not these 2, not this one. This one is for the formula. If you put 2 volumes of hydrogen, this is wrong. We are looking at what is behind here. 1 volume of hydrogen reacted with 1 volume of chlorine to form what? To form 2 volumes of hydrogen chloride. That's the statement, right? Now, what concerns the question is hydrogen and the chlorine. So take hydrogen and chlorine alone. So if 1 volume of this reacted with 1 volume of this, so now suppose 100 cubic centimeters of hydrogen reacted. hydrogen reacted. And also 1 volume of chlorine did the same. So meaning this volume is the same as the one of chlorine that was what? Reacting. Because of this 1 volume, 1 volume. So if this is 100, the rest remains what? 100 cubic centimeters. So the volume of chlorine used is 100 cubic centimeters. Is that clear?
Yes, teacher.
Okay. Let's proceed. The second question, B, says the volume of the gaseous product formed. Where is the gaseous product formed? It is this one. Okay? The volume of the gaseous product formed is this one. So you say they gave you hydrogen. So you say 1 volume of hydrogen reacted, okay, produced this time, produced 2 volumes of hydrogen chloride. If this volume is 100 cubic centimeters, what was the volume of a gaseous product formed? It is 2 times what? 100, which is 200 cubic centimeters of hydrogen chloride produced. You are not considering masses, you are only considering the volumes. Okay?
Yes.
So here they are saying 1 volume of this combines with 1 volume of chlorine. So 100 of hydrogen also combines with 1 out of 100 times that, all the thing remains the same, 100 grams of cubic centimeters of chlorine. From the equation, even here they are saying 1 volume of hydrogen produces 2 volumes of hydrogen chloride. So if 100 of hydrogen were the ones reacting, then it will give us 2 times 100 cubic centimeters of hydrogen chloride. That's the volume of the gas produced. Is that clear? Yes?
Yes, teacher.
Good.
Yes.
Yes.
Now they are saying 80 cubic centimeters of oxygen, 80 cubic centimeters of oxygen are exploded with 80 cubic centimeters of hydrogen. The equation of reaction will be between what and what?
Oxygen and hydrogen.
Oxygen and hydrogen. So hydrogen and oxygen gives us what? This is a gas. This is a gas. What do you form?
Hydroxide.
Hydroxide.
You form water, not hydroxide. You form what? You form what?
Water.
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 That water will be in a gaseous state. Okay? Now, is this question balanced? Is it
No.
balanced?
No.
So what is missing?
No, the
Yes?
oxygen. Oxygen is
What should you do?
that.
What should you do
Add
to oxygen?
2.
Add 2.
No, on the water.
In the water, you put 2.
Then on the hydrogen, you put 2
You
also.
put 2. Now, write what concerns the question. What is the question about? Determine the volume of the unused gas. Unused gas. Because they are telling us 80 of this reacted with 80 of this. But we want to prove that maybe there is some gas of oxygen that was not used. So which one do you consider? Because they are saying 2 of hydrogen, if you consider volumes, 2 volumes of hydrogen reacts with what? 1 volume of what? Of oxygen, isn't it? Now, if 80 means 2 of these ones, if 80 of hydrogen was exploded with this, which gas was unused? Which one was exploded with the other? It is oxygen, isn't it?
Yes, teacher.
So here they are trying to mean which one of the gases was unused. Was it hydrogen or oxygen?
Mm,
Which one was exploded with the other?
Oxygen was exploded with hydrogen.
So we expect to see a certain volume of a gas that remains in our equation. So here they are saying someone is unmute. Yeah, now there it's okay. Good. So here we are having 2 volumes of this reacted with 1 volume of oxygen. Now, if this one, for it to explode in, if this one to explode in this, you need 2 of these ones. Therefore, the volume of hydrogen will be much more than the volume of what? Oxygen. So you say 2 volumes of hydrogen reacted with 1 volume of oxygen. What about 1 volume of hydrogen? 1 volume of hydrogen reacts with 1 out of 2 volumes of oxygen.
Oxygen.
So the volume of hydrogen that was given was what? 80 cubic centimeters of hydrogen. Reacts with
Teacher.
what? Yes.
Just explain how that a half comes about.
This is 2. This is 1. So if you want to get 1 volume of hydrogen, what do you do this side? You divide by 2, isn't it?
Okay.
Okay. So 80 cubic centimeters of hydrogen reacts with a half times 80 of oxygen. Cubic centimeters here. So a half of this is what? 40 cubic centimeters. So you see, for you to explode hydrogen, you need a half volume of the hydrogen here for it to react. So if you use 40, you will use all the 80 of the hydrogen. Okay? So some part of the gas remained unused. That part of the gas was the one of oxygen. So oxygen used was 40, but the one they used was 80. So the unused gas, unused, becomes, if they used 80, then if they brought 80 of oxygen, they exploded it with 80 of hydrogen. It means you needed only 40 of oxygen to explode the all 80 of hydrogen. So it becomes 80 minus 40, which is the same as 40 cubic centimeters of oxygen and what? Unused. Is that clear?
Yes, teacher.
Okay. We have less than a minute to come back for the second session. If you have questions to ask, this is